Alright, ladies and gentlemen of period 7/8. I'm going to try this again. I've tried this a bunch of times. Internet knocked me off a couple times, lost my connection to YouTube, and then people interrupted me a couple times. So I'm going to go maybe a little quicker than I usually would, or that I did in the last couple classes. Question I have for you, to start with, you're given this original triangle M. It's on your paper. You may want to just label these other three triangles M1 for triangle 1, M2 for triangle 2, and M3. They're all images of this original pre-image. And I want you to answer these three quick warm-up questions. What maps M to M1? What maps M to M2? And what maps M to M3? Now in class I would pause and give you a minute to do this, so I'm not going to do that right now to speed this thing up. Hit pause, try to answer these three questions, and then check out my answers. If you look at M to M1, that's a reflection. Specifically, it's a reflection over this vertical line over that y-axis. So I want to try to be a little more specific than you were yesterday, whereas yesterday we were just learning these words, reflection, rotation, and translation. M to M2 is just a slide downwards. Another word for a slide is a translation. And then M to M3, most of you can see, is a twist or a turn or a rotation. And specifically, it's 90 degrees. And you might also have the word counterclockwise. It's going counterclockwise on there. The fourth little refresher question on your paper is, which of these transformations appears to be isometric or rigid? And this is just, and it also says Y on there. That important part of that is explaining, kind of refreshing the definition of isometric. And yeah, it's supposed to be obvious. They're all isometric. In other words, all of these triangles are the exact same size and the exact same shape. They're all congruent triangles on there. Isometric, again, is just a synonym of congruence. So like the green angle here would be congruent to the green angle here, and the green angle here, and the green angle here. They're congruent in every situation. The side lengths, green to yellow here is the same as green to yellow here, or green to yellow here. So they're all congruent. Another way you could say that is the size here is the same as the size here, and the shapes are the same. So size and shape are preserved, which you can't see on your screen until I do that. So that's another way of explaining that. Just kind of refreshing the three words from yesterday, and then the words isometric and rigid. The rest of these notes are reflection specific. So you're going to take this given triangle BMW, plot these 3 points on the graph, and then I want you to reflect them into the x-axis. So reflect them, basically flip them over the horizontal line there. I would, in class I would pause this and then let you work. Right now I'm going to just blast through here. So -4, -2 is down here, -1, -2 is here, -2, 0 is on the actual x-axis. And then I want you to do this reflection. So there's your pre-image. Now find B prime, find M prime, and W prime. And it's kind of obvious for some of you. You're just going to flip this over. So it's 2 down here. Now it's going to be up 2 from the x-axis. This one's 2 down. This one's going to be up 2. And of course, M prime doesn't even change. M is the same as M prime. Every one of these problems we approach today, we want to approach it sort of on 4 levels. One is verbal, which is given to you here. The second level is graphically or visually. That's the second part of it. The third part of it is numerically. So I want you to look specifically at these coordinates of B prime, M prime, and W prime, and write them down right next to the given original pre-image coordinates. And I want to look at this problem. So we're looking at it verbally, given. Graphically, you did that. Look at it numerically now. And then the fourth part, it says on your paper to write a function rule. Can you do this algebraically? Can you write a rule for anything reflected in the x-axis? But you kind of have to do it numerically to kind of get that, I think. So if you look at -4, -2, that's now flipped. Now it's -4, +2. -2, 0 didn't change because it was on the actual mirror line. And the last one, W prime, is now -1, +2. If you just look at these numbers from here to here, from here to here, it's pretty obvious what changed. Most of you look at it and go, oh, well, the y-coordinate changed. The y-coordinate went from negative to positive. If I went the other way, it would go from positive to negative. So the way we write that as a rule, this is a little r sub x, in other words, a reflection into the x-axis, would map a point, xy, an original point, would map it to x negative y, in other words, the opposite of y. So this is sort of 4 levels of every problem. We've got verbal, we've got a visual understanding of it, we've got a numerical understanding, and now the big one, we've written a rule for anything reflected in the x-axis. If I give you the point, 10 comma 4, you could go, oh, if I reflect it into the x-axis, it's going to be 10 negative 4. You can quickly kind of get that from this rule and from your understanding of these other concepts on here. So the second one we're going to do, I'm going to pause the video here so I don't lose all the recording. The second one, and don't worry about this question right now, I'll come back to it later, is reflecting this triangle PRE with these given coordinates into the y-axis. Like I said, I'm going to pause it because I've had this thing disrupted a couple times and I want to make sure I get a good recording in here. Okay, so try that one. I'll be back in a minute.